Okay, so today we're going to continue with chapter 10. We're going to cover section 2, and we're going to learn about arc measures. So the first thing we're going to talk about is a central angle. And a central angle is an angle whose vertex is the center of the circle. So we could see that angle ABC is a central angle. Notice the vertex of this angle is the center. So it's point B here. Now, there's more than one central angle in this circle, but the only one that's drawn here is the vertex, the angle ABC. Notice the sides of the central angle are made by two radii. So the two radii will form the sides of your central angle. If I were to add another point here, let's say I call it point D, I could also name another central angle, and that angle could be DBC. So angle DBC could be a central angle. I could also name it as ABD. But notice in all of the ones that I've written here, the middle letter is the point B, which is the center. So again, the vertex is going to be the center of the circle. And the sides of the angle are using the radii. Next, we're going to learn about arcs. An arc is a broken part of a circle. When you have a minor arc, it will be an arc that is less than half of the circle. So it's going to be less than 180 degrees. Arc measures are measured in degrees. When you have a semicircle, it'll be half of the circle, and it will be exactly half of the circle, so it will measure 180 degrees. When you have a major arc, the arc will be greater than half of the circle, so it's going to be greater than 180 degrees. So minor arc less than 180, major arc greater, and semicircle arc will be exactly 180 degrees. It's a semicircle, half of the circle. Oops, I didn't want to add a page, but okay, so now let's look at this circle. We're going to identify a minor arc, a major arc, and a semicircle arc. Okay, we have a diameter here, and it's labeled as DC. So arc AC is a minor arc. So the arc length is going to be the distance around this outside. That's the arc. The symbol for an arc would be, you write two of the letters for a minor arc, and you draw a picture of an arc on top of it. For the major arc and the semicircle arc, we are going to name it with 3 letters. You could name the minor arc with 3 letters, but all we need are 2. So in this figure, AC is a minor arc. DAC is the semicircle. It's the endpoints of the diameter. And then the major arc, and the order of the letters is important. The order of the letters tells you the direction that you're going to go around the outside of the circle. So when we're talking about major arc ADC, we're starting at point A, we're going this way to the D, and then around to the C. And that would be your major arc. And you will need 3 letters to name the semicircle and the major. Because if I were to only name the semicircle with DC, I wouldn't know which side of my circle I was talking about. So name it with 3 letters so you know the direction to follow. Next, we're going to look at the measure of an arc. Notice this little lowercase m in front of the capital letters. This is indicating that it's a measure. The measure of the arc will always be in degrees. So, for our measure of an arc, the measure of an arc is equal to the measure of its central angle. So, in this figure, we can see that we have central angle ABC. So this could tell me that the measure of AC, this arc, is also going to be 50 degrees. Good. Now, the other measure that I have on here is going to be the semicircle arc, because I know a semicircle has 180 degrees. So for my CAD, it's going to be just the semicircle, so it's going to be 180 degrees. For the ACD, and we're going to follow it around in the order of the letters. So when I go from A to C to D, this one, notice you're going to add the 50 plus the 180, and you get 230 degrees. So coming up in a future slide here, we're going to learn the arc addition postulate. Remember, we had the segment addition postulate and the angle addition postulate. So we're going to be seeing the arc addition postulate. So again, these are the symbols for an arc. They're drawing like a little picture of an arc on top of the capital letters. So the measure of the arc is the same as the measure of its central angle. Adjacent arcs. So remember, we talked about adjacent angles. So remember, the vocabulary word adjacent means next to. So I'm looking for two arcs that are next to each other. Arcs that have exactly one point in common are adjacent arcs. So for this one, the arcs can't overlap and they can't have something in between them. So an adjacent arc could be QR is next to RS. So if I write QR is adjacent to RS, notice the point in common is the point R. Okay, I couldn't say that QR is adjacent to ST because there's no points in common. QR is over here, ST is over here. They're not next to each other. Now I could say that QT and all the arcs that are adjacent to that could be TS over here, or I could go this way and say QR. These are all, this is adjacent to this is adjacent to this. You could name it the other way also. You could name it backwards, you could say RQ, so the order doesn't matter. But they have to have exactly one point in common to be adjacent. Next, we're going to see now the arc addition postulate. So the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So the two that are next to each other, when you add them together, can make a larger arc. So this is just like our segment addition postulate and our angle addition postulate. So if I were to add AB plus BC, that would give me the total measure for ABC. So add the two little pieces to make one larger piece. And again, it's the arc addition postulate. Congruent circles and arcs. So again, we saw yesterday, congruent circles are circles with equal radii. Congruent arcs are going to be arcs that have the same measure. and they are arcs of the same circle or of a congruent circle. So I'm going to draw in some examples here. Okay, so I'm going to make a red circle first. Can you guys, yeah, I guess you can see that. Okay, then I'll make a blue one. Sort of supposed to be the same size, but close enough. And then I'll do a green one. All right, so I'm going to add in some points. So let's say I have A, C, E, F. And let's say this one's 80, this one's 80, and the radius is 3. I can see here that I have two congruent arcs because I know that the arc length is the same as the measure of its central angle. So I could see that since the central angle of, let's see if I put another letter in here and make this the center B, I could say that AC, that minor arc, is congruent to EF because their central angle measures are the same. Now I could draw in my blue one. I could draw in a radius length of 3, an angle measure of 80. I could call this point L and this point M. Notice by my definition of congruent circles, circles with equal radii are congruent. So notice they both have a radius length of 3. So my red and blue circles here are congruent. Notice also that my blue circle has a central angle measure of 80. So that tells me that arc LM is also 80 degrees. So I could also say that AC from the red, maybe I'll do this in red, the arc length from AC is congruent to the arc length from the blue, the LM, because they both have 80 degrees and they both have the same radius length. For my green circle, I'm going to add in points. Yes? Yes. So if I put point B here, point N here, and let's say I make a center here, but my radius length is 5, even though this has 80 degrees, my circles aren't congruent, so I cannot say that BN is congruent to AC because this arc length is going to be, appears to be longer. And then what we're going to see later on coming up, that if we were to take a string and measure this, it wouldn't be the same length. So this would not be congruent because the circles are not congruent. So the blue and the red are congruent circles. They have the same radius length and their arc measures are congruent. Example 1, we're going to name two minor arcs. Can somebody give me a minor arc in this figure? RA, good. Let's do this. Do the minor ones. RA. You could have also called it AR. The order doesn't matter. Okay, can somebody give me another minor?
RC.
Okay, RC. Or you could say CR. Pretty good on that? It has to be less than 180 degrees. Can someone name me two major arcs? Okay, Bella?
RAC.
RAC, so she's going around past the 180. Good. Can somebody give me another one? You could also go backwards. You could call it car. Kimberly?
CRD.
Okay, CRD. So now she's going this way. C to R to D, and that would be major. So CRD would be a major. You could go backwards and say DRC, and then put the picture of the arc on top. So those would be examples of the major arc. Can someone name a semicircle? Gabby.
ARC.
Good. ARC could be the semicircle. ARC. Can somebody name another one?
CDA.
Okay. CDA. Good. Gabby, you have another one?
Did I say
DAR.
DAR?
We don't have a segment there, so we would just have to focus on these. We could say these backwards. So ADC, ARC, we could say it as CRA and ADC. So we could say the letters backwards. But we have to base it off the diameter. All right, next one. An acute central angle. Bella.
AOR.
Okay, good. AOR would be a central angle, and put the little angle symbol in front. Can someone give me another one? We could also say ROC. And you could go the other way, as long as the O is in the middle. Yes.
Are those obtuse angles?
All right, you got to go in the order. So if we went A to O and R, let's see, it's not really showing. AOR would be here. Actually, no. AOR is less than 90. It would be less than, that would be acute. So just ROC would be obtuse. It would be greater than 90. So let's just do the AOC. Yes. Does that make sense?
Mm-hmm.
If it were straight up and down, then we could tell that it's 90. So just AOC. All right, what about two congruent arcs? Do we have any angle measures in here? No, right? But what do we know?
Semicircle?
Okay, we know the semicircle. So we can't assume angle measures here. So we only know the semicircle. So the two congruent arcs could be ARC, congruent to ADC. Those are the only congruent arcs we know for sure. The ones that are the semicircle. Okay, so it wants us to give the measure of each angle or arc. Let's go ahead and fill in our picture. Again, let's think of this as like a puzzle. So notice that when we have a central angle, we know the arc length is going to be the same. So, okay, so for arc length XY, I can see it's going to be the same as the measure of angle XOY, which is 30. Also, I have an arc length measure over here of WT, which is 50. So then I know central angle WOT or TOW is also going to be 50. And I should probably do this in a darker color. How could I find XW?
You add and subtract. Like the semicircle equals 180, so add and subtract.
Good. So I'm going to add the two that I have, and I'm going to subtract it from 180. So 30 plus 50 is 80. Subtract that from 180, because that's the semicircle. So I know that this will be 100, and the same thing for its central angle. So now I can go back and answer my questions. So WX is going to be what I just figured out, and that's 100 degrees. Remember, arc measures are in degrees. Then angle WOT, we found that is the 50 degrees, which was from the arc length that was given. And then XYT, that one I got to work for. Notice you have the semicircle, so let's follow it around. So for that one, we could go, maybe try green. So XYT, so if I start here, X to Y to T, I have the 30 plus the 180, giving me a total arc length of 210 degrees. And then last, it's asking to find the measure of YOT, So Y, O, and T, again here, is going to be the semicircle. So it's 180 degrees. It's a straight line. Yes. All right, any questions on this slide? Okay, so that is 10-2, your arc lengths, your central angles, each of your different arc types. Your homework is practice A. We will reinforce this again tomorrow. And then on the next day, we'll start 10-3. You have a quiz on this next week on Wednesday, so a week from today, on 10-1, 10-2, 10-3. So tomorrow we'll reinforce this. Friday we will learn 10-3. We'll review everything, the 10-3 on Monday, and then Tuesday we'll begin reviewing for the quiz. It'll be the last grade of the quarter, the last major grade. Any questions?